Okay, so now that we have looked at electric circuits, both series and parallel, I want to do something today called equivalent resistance. This is a kind of an important thing to do when you're dealing with circuits that are a little more complicated, right? The ones that we did were pretty simple. But typically, an electric circuit might be extremely complex. It might have a resistance here, and then it might branch into, three different resistances along a path like this, and then this path might come down like this, and might join over here, and join up with that path. There might be another path here, and over here with a resistance. And of course, I could draw a very complicated kind of circuit, and how would we deal with that? I mean, how would we even begin to look at how something like that worked? So what we're going to do is we're going to start small, and I'll do a simple version of it. Equivalent resistance is just a way of figuring out the resistance of a section of a circuit. The resistance of a section of a circuit. It's what resistance or that section of a circuit is equivalent to what in terms of resistance? The resistance of a section of a circuit. Okay, so let's take a nice, easy example. Let's say we had a circuit, and I'm only going to draw one little piece of it. So it came over this way, and there was a resistance right here. And then there was another resistance here, but this part of it happened to be in parallel. Remember, two paths means parallel, and one path means series. So the rest of the circuit goes this way. I'll put an arrow here to show that the circuit doesn't finish. Obviously, circuits have to join up with each other. This is just one little piece that we cut out. And what we want to know is, what is the resistance of this piece? Well, let's say that this resistor is 2 ohms. And let's say that the two resistors here are 3 ohms and 6 ohms. All right, so what we do is we look at the circuit and we try to decide whether or not we're dealing with series or parallel. Well, if we look at the first resistor right here, resistor number 1, we'll call this guy 2 and this guy number 3. Resistor number 1 is all by himself on one path. So there's not much we can do with him. But when we get to this magical spot right here, the current splits, which means that these two resistors are on two different paths. So this little piece of the circuit is parallel. So what I'm going to do is I'm going to use Kirchhoff's laws for resistance in parallel. 1 over 3 plus 1 over 6. Right? Now, this is an easy one to do in your head because that's the same as 2 over 6 plus 1, over 6, right? And that equals 3 over 6. And so, well, you know what? Let me write this so you don't get confused. Let me just kind of continue it over here. I'll put a line. So 1 over RT equals 3 over 6. Well, 3 over 6 is 1/2. And so if I do the reciprocal, RT over 1 is equal to 2 over 1. So I've discovered that this little piece right here, this entire section of the circuit, has a total resistance of 2 ohms. You see that? That's its equivalent resistance. So then I can go back to my original picture, and instead of drawing that, I can just draw one big resistance here, and I know that it's 2 ohms because I just figured it all out as 2 ohms. And this is 2 ohms. So that means now I have two resistors, but they are in series because they have only one path. And in series, total resistance is added just naturally, just normally. So this would be 2 plus 2 equals 4. So that means that my whole piece of circuit, therefore, the resistance of the entire piece of circuit is 4 ohms. And that's the equivalent resistance of this piece of circuit. This entire piece, this whole thing. So if you were to stick that into an electric circuit, we would know that this section had a resistance of 4 ohms. Now, the only thing you have to remember is when you should be using the parallel kind of addition, the reciprocal addition, or when you should be using the series addition. And basically, it all comes down to whether or not you're on one path or you're on 2 different paths. So let's do another example that's a little more complicated. Now, instead of drawing all the resistances, I'm going to make it a shortcut. I could put the little sign here and then put 2 ohms, but if I just put 2 here, we're going to understand that means 2 ohms of resistance. Now, I'm going to draw a little line up here like this, and I'm going to put 3 ohms up here. And then I'm going to draw a line down. Now I'm going to draw a line this way, and I'm going to put 1 ohm here, and let's put 4 ohms here. And then I'm going to have another path here, and we're going to put 2 ohms right there. And that's going to be our piece of circuit. All right. So, first sort of step is to look for any resistances, all resistances on the same line. All resistances on the same path are series. That's what series means. So if I look at my picture, I can see that there are 2 resistances right in the middle, right here, the 1 and the 4. They're both on the same path. There's no way you can go through the 1 and not the 4. So since they're both on the same path, these 2 guys are in series. So that's the first thing I'm going to do, is I'm going to add them together, right? And I'm going to add them together using the series rule. Resistance is 1 plus 4 equals 5. So now I'm going to redraw the picture, because it'll be a little bit simpler this time. I'll go up like this and over like this. I think it was 3 on the top. Yeah. So that 3 we didn't do anything with. But see that middle path? We've now turned it into 5. And then on the bottom here, we have a 2. So that's the first thing that we've done in our circuit. Now, the next thing we can do is look at this whole section right here. It's a parallel section. There are 3 paths that the electricity can follow. So I'll find the resistance of this parallel section using the parallel rules. 1 over the total resistance of this part will be 1 over 3 plus 1 over 5 plus 1 over 2. Right? Now you can do the common denominator, or you can use the shortcut I told you on your calculator with the 1 over button. You can press 3, 1 over, plus 5, 1 over, plus 2, 1 over, equals, and then press 1 over one more time, and what you get here is that RT equals 0.97 ohms. So that means that this whole section right here, all of this piece in here, is really just the same as 0.97 ohms. So now I can redraw my picture even simpler. I have a 2, and now I replaced that whole section with 0.97 ohms. See that? And the last step is I'm now got a series. I've got only one path. So now I will use my series rule. RT equals 2 plus 0.97. So the answer is a circuit, and it's just 2.97. That's the resistance, the equivalent resistance of all of this big piece of circuit that I drew up here. It's like having one big resistor of 2.97, and that would be ohms, right? Yeah. And of course, you don't need to draw this in. I was just showing you. 2.97 ohms. All right. Now I'm going to show you how you can do it a little bit easier with just without drawing all the pictures over and over and over again, right? So watch. Let's take this guy. Let's put one here, 2 ohms and 4 ohms. And then we'll do a piece here, and we'll go up and over, and we'll put 3 ohms here. We'll go down and over and put 2 ohms, and then 1 ohm, and then over here, we'll go down and up like this. Oops. And then we'll also go down here, we'll put 4 ohms here, and over here, 3 ohms, and then we'll link up here with here, and lastly, we'll have 2 ohms out here. So there's a big piece of crazy circuitry. All right. Here's what we're going to do. We're going to break this down as much as we can without redrawing it. Let's look at this section. This section right here is parallel. So I can do my parallel rules, right? I can do the total resistance of that. 1 over the total is 1 over 2 plus 1 over 4, right? Well, that's 2 quarters plus 1 quarter, which is 3 quarters. So RT is 4 over 3, 4 thirds, or that equals 1.33. So now I know this is 1.33. And I'll cross out the 2 and I'll cross out the 4 because I've added them up. Good. Next step, I can look at the next part. Oh, look here. I have a 2 and a 1 on the same path. If they're on the same path, then the resistance is just 2 plus 1. They're series, so you don't have to do the 1 over. So that's equal to 3. So I can just cross those out, and I can write 3 on there. Now, I also have one path. I'll do it in purple here. Look at the 4 and the 3. They're also on the same path, right? There's only one way through them. So I can cross them out and add them up to one big 7. All right, fair enough. Now, look at this crazy section right here that I'm going to put in green. Keep your eyes on that. It's really just a parallel section, and it's got a 3, and a 7. So I can do the whole green part, right? It's basically, oh, wait a minute. Let me go back here. I think I might have jumped the gun. Let me go back here. They're really not all the same path, are they? I think it might make more sense if we start with just these two. Just this section right here. Yeah, let's look at that one first. Let's not get ahead of ourselves. Here we have 2 parallel pieces. So I can figure out this green section by doing the total. 1 over the total resistance is 1 over 3 plus 1 over 3, right? Well, that's equal to 2 thirds. And so that means that RT is 3 over 2, which is 3 halves. Well, 3 halves is 1.5. So that's 1.5 ohms. So I can cross those numbers out and I can write 1.5 for that green section. Now, I suppose I could have done it all at once, but I'm doing it in steps because I don't want you to ever make a mistake, right? So now I can look at this big section that I had before. I'll do it in blue now. Let's look at all this. Looking kind of crazy, but really, what do we have? We have 1.5 across the top, and we have 7 across the bottom, and that's parallel. So I can do parallel rules. 1 over RT equals 1 over 1.5 plus 1 over 7. When you have a decimal in the fraction, you pretty much have to use your calculator. So you press 1.5, you press your 1 over button, and then you add that to 7, 1 over button, equals, and press your 1 over button. And that means that RT for this is 1.24 rounded off. Okay, so I cross out all my numbers, and this is just 1.24. So now look what I've done. I'm able to reduce it to this, 1.33 for the red part, 1.24 for that great big middle part, and 2 left over on the end that's still over here. And now it's all in one line, so I add it up. So 4 and 3 is 7, 3 and 2 makes 5, and then 2, 3, 4.57 is the total resistance, ohms. So you see, you can kind of work on the picture. Even though it gets all messy and it looks crazy, you don't really have to ever go back to the picture anyway. So you just kind of do it like that. Okay, we'll do one more example together, and then I think you'll be all set to try some on your own. So let's draw another picture here. Let's draw 3 ohms here, and let's bring the circuit down here to 4 and 2, and then up here, 3, 2, and then over here we'll go 4 ohms, and then we'll come down like this, and we'll have another section with 2, 1, and 3 ohms, and then we'll join those all up like this, and this will come around like this. We'll bring it down here, join it up with that, like that, and that'll be the end of it. How's that? Okay, so to make that look a little better, why don't I get this bend out of here? Let's just bring it forward, and let's go down like this, 2, and over there. There's our circuit. We want the equivalent resistance. Well, let's look at what we can do here. 4 and 2 are on the same path. So those 4 and 2 on the same path make 6. Series, add them up, regular. These two are in parallel. So I add them up, 1 over 3 plus 1 over 2 equals 1 over the total resistance. And so if I maybe just jump that into the calculator really fast, 3, 1 over, plus 2, 1 over, equals 1 over, and I get 1.2. So I know that this is 1.2. Never mind that, never mind that. Now it's just like a straight piece, see? Then I can go down here to this section, and I have a parallel section. So I have 1 over 2 plus 1 over 1 plus 1 over 3 equals 1 over the total resistance. So I'll just use my calculator, and I'll go 2, 1 over, plus 1, 1 over, which is just 1, plus 3, 1 over, equals, and then 1 over. And I will get 0.55 for the total resistance, ohms. So I can cross these guys out and just write in here, anywhere, 0.55 for this section through here. Good. Now, I can look at this path across the top. I have a 1.2, a 4, and a 0.5. And they're all on that same path. So I can put them all together by adding. So that would be 5.75. 1.2 plus 4 plus 0.55. That's hard to see, but it's 1.95. No, where am I at here? 4. Whoops. Let's do that again. 4 and 1 is 5. I'm going to write that in a different, well, I guess not. 5.75. Yeah, I think that's what we said. All right. Now, let's look at the entire piece. Let's look at all of this at once. Because what I have is one path across the top, which is this, 5.75, and one path across the bottom, which is 6. So I can do 1 over 5.75 plus 1 over 6 will be 1 over the total resistance. And I can crunch it into my calculator. 5.75, 1 over, plus 6, 1 over, equals 1 over 2.94 is the total resistance of this whole section. Well, if all of this is 2.94, and this is a 3 over here, then the total resistance of the whole circuit, whoops, I got to go back down, will just be the 3 plus the 2.94. There we come. Here it comes. A little further. All the way down. There we go. 3 plus 2.94. So the answer would be 3 plus 2.94, which is 5.94 ohms. So you see how you can kind of work through it sort of a little bit at a time. All right? So I'm going to give you in the assignment section, you'll see there will be a little assignment where you have a couple of these to try on your own.